Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is shortest XY distance in a grid. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. So let's get started. Here is the problem statement and it says that given an n cross m grid of characters O, X and Y, okay, find the minimum Manhattan distance between a X and a Y. Okay, so Manhattan distance is given by this formula. It basically says that Manhattan distance is the sum of difference between rows and the difference between columns. Okay, let me explain this. If I have X here and I have O here, so the minimum Manhattan distance between these two will be given by like this plus this. What is the difference between rows and what is the difference between columns? It will be 1 2 3 4 5 6 6 for this X and O. Okay, now I hope you guys are clear with Manhattan distance. Now I am going to talk about this example. Okay, so this example says that you're given a grid and you have to find the minimum distance between X and Y. Okay, so let's consider this pair. This pair have a distance of like, okay, this pair has a distance of 1 and this pair has a distance of 2. Okay, this pair has a distance of 4 actually, and this pair has a distance of 2. After that, this pair has again a distance of 2. This pair has a distance of 1. Again, this pair has a distance of 1. After that, this pair has a distance of 3. And there are more possibilities as well. Out of all the possibilities, I have to return the minimum. So the minimum you can see here is 1. So that's why 1 is going to be the output. Now, I hope you guys are clear with the problem statement. Now let me talk about the solution. Okay, so first of all, I'm going to write the same example again. Example is X O O O. Okay, it is X O O O. After that, I have O Y O and Y. After that, I have X X O and O. After that, I have O Y O and O. Okay, now whenever we talk about shortest path, the first thing that comes to my mind is BFS. BFS is breadth first search, and you know one of the application of BFS is to find the shortest path in a graph or a grid. Okay, so this means that we can apply BFS here. What we can do is we can traverse the whole matrix for row in grid, and for each row, for each column in grid. Now again, I'm going to check for each row and column. If current element is double equals to X, then I can perform BFS. Okay, so when I perform BFS, then I find the minimum distance of the like shortest path between this X and this Y. So the minimum distance between this X and Y is 2. Okay, I do the same for this X as well. It gives me the minimum. Okay, first of all I have 2 here. For this I have 2 again, and for this X I have 1. Okay, so out of this I'm going to return 1 because 1 is the minimum. So I need one variable which is minimum, and this minimum is going to keep track of minimum, and after that I'm going to return this variable. Okay, now I hope you guys are clear with this approach. This is simple and easy to understand approach, but okay, we will talk about the time complexity later. First of all, let's see the code. Okay, so I have the code here. Now you can see that here on the left side I have Java code and on the right side I have C++ code. Okay, let me move to the starting point of the code. Okay, so this is the point from where I'm going to start. Now if you see here, then you will find that I'm going to perform I'm going to traverse the matrix, and when I have X, then I'm going to perform BFS. Okay, now what is BFS function? Let's talk about BFS. So this is the BFS function, and as any other BFS function, this function is going to have one queue and one visited array. You can see that visited and queue. Okay, I'm going to push my starting index in the queue, and after that I'm going to find the first occurrence of Y. So whenever I find Y, okay, I have not written here, let me write it. Whenever I find Y, then I'll simply return because I need the shortest path. Okay, so you can see that when I have Y, so I just need to return. Okay, so this is how we are performing BFS. Basically we are going to check for each neighbor here. You can see that we are going to check for each neighbor. Okay, now I hope you guys are clear with like how we are performing the BFS, and if you want this code, then I'm going to provide the link of the code in the description box. Okay, so now let me move to the next approach. But before moving to next approach, let me talk about the time complexity of this approach. Okay, so time complexity is, first of all, we are performing n cross m loop, and for each loop when I find x, then I'm going to find the minimum distance of x and y. Okay, so for this the time complexity can be like max distance of x and y, isn't it? Why? Let me tell you. For this, let's take, okay, so for this y, maximum distance between, actually let's first of all let me remove this, let me take another matrix. I have x o o o, and then I have x and y here, and then I have o o o and o. Okay, so you can see that this is the maximum distance between x and y, like it is 1 2 and 3, and for this it is only 1. So when I perform BFS for this, so the maximum possibility is the max distance, so that's why I'm writing the max distance between x and y. This is the time complexity. Okay, now let me talk about the second approach that I have. Okay, so I'm going to write the same example again. I have this as my example. Okay, fine. Now the second approach that I have is, first of all, let me write the index here, like it is x1, it is x2, it is x3, it is y1, it is y2, it is y3. So what I can do is I can consider every possible pair. Like for this x1, I can find the distance of this x1 from y1, I can find the distance of this x1 from y2, I can find the distance of this x1 from y3. This is the first I have. Secondly, I can do x2 y1, x2 y2, and x2 y3, and x3 y1, x3 y2, x3 y3. Okay, so my answer is going to be one of this. So why not to try all the ways? Like you can call it brute force approach. Brute force. Why? Because I'm trying out all the ways. Okay, so for every possible pair of x and y, find the distance and just return the minimum distance. Okay, now let me talk about how we are going to achieve this, how we are going to do this. First of all, I'll create a list. Create list x indices. This is going to store every occurrence of x. Okay, after that, create list y indices. Okay, this is going to store every possible occurrence of y. Fine. Now I can do something which is, okay, first of all I will do a n cross m traversal, which traversal is going to fill up this x and y list. Okay, fine, I'm done with this. After that, for each value, in x indices, I will check for each value in y indices. This is what I'm going to do. Like it is a nested loop which is going to check for all the possibilities. So I have every pair x and y now at this position. So I'm going to check, like calculate Manhattan distance. And when I have Manhattan distance, then I can minimize it, like min equal to minimum of min that I already have and distance. Okay, and at last I'm just going to return the distance that I have. So this is the second approach that I have, and let's check the code for this approach now. Okay, so this is the code for this approach. In Java, we do not have a pair class like I have here. You can see that C have a predefined pair class, and this pair class is basically going to store the current indices, like any cell is going to represent any cell. Like I have to represent a cell using I and j index. So this is what is achieved by this pair class. So that's why I have made pair class here as well. Now I will create a list of pair which is x indices and a list of pair which is y indices. Fine. Similarly, I have created here. After that, in this loop, I am going to fill this x indices and y indices. You can see that. Like whenever I have x, I am going to put the coordinate into x indices, and whenever I have y, I am going to put coordinate in y indices. Fine. After that, what I can do is I can check for each pair. Like you can see that I have every pair here and every pair for y, x and y, and similarly I am doing here. I am calculating the minimum Manhattan distance here using this formula, and after that I am going to minimize it. Okay, now I hope you guys are clear with this approach as well. So let's talk about the time complexity of this approach. Once, okay, so let's talk about the complexity. What we are doing is, let's take a case. Okay, so what we are actually doing is, first of all we are doing n cross m traversal to fill like x indices and y indices. Okay, after that I'm doing a traversal between these like a nested loop of the size of this x indices and y indices. So let's take the size of x indices is a and the size of y indices is b. So a cross b is going to be this is going to be the complexity. Okay, so what is this complexity? Can we write this in terms of n cross m? Let's try to do this. If I have a matrix like x x dot dot dot, I have x here, and in the first column I have x, and after that in the last column I have y, and in the last row I have y. Okay, after that in the middle I have o only. Fine. So what is the size of, like, if I store all the x and it is m and it is n rows and m columns, so what is the size of this x? A is going to be n plus m. Do you have any doubt? No, I don't think so. And after that b is going to be like, okay, it will be n minus 1 plus m minus 1, but let's take it close to n plus m. Okay, fine. So when I do a cross b, then it will be n plus m whole square, and it will be, I hope you guys are understanding this what I'm trying to write here. It is an example. I'm just taking an example. So this example is going to have the size of x indices as this one, because I have first row and first column filled with the x. Okay, so similarly for y, and when I open this I have n square plus m square plus n cross m, 2n cross m. Fine. I can surely say that this is something which is going to be greater than n cross m, this term. Okay, so I can write my complexity as O of n cross m will be like, okay, my complexity is going to be greater than O of n cross m. This is smaller and my complexity, like this one, is greater. Okay, fine. Now I hope you guys are clear with the two approaches that I have explained you. So now let me move to the third approach that I have. Okay, the third approach that I have is dynamic programming, and this is really very interesting to understand. Let me explain this. I'm going to write the same example that I have x o o o, and I have o y o and y, x x o o, and last column is this. Okay, last row is this. Fine. Now see this y. This y is going to ask from all its neighbors that, hey, what is your minimum distance from y? Like, what is the okay, x, what is the nearest x that you have? Okay, it will say that I have nearest x at a distance of 1. So the up one says that I have nearest x at distance of 1. Okay, then it asks from this left one, it says that again I have nearest x at a distance of 1, and the right one says that from me the distance of nearest x is like 1 2 2. Okay, fine. And the last one says that I am x, so distance of me from me is 0. Okay, and this y has to find the minimum distance of x from itself, so it will choose the minimum from all these, there is no doubt. So it will say that what is the minimum value of up, down, left and right neighbors. Okay, so it will say that, okay, minimum distance is 0. So now what you are going to do, it will say that, okay, you are at distance 1 from me, like this distance is 1, so I am going to have minimum distance as min plus 1. So this is the distance of y. I hope you guys are clear. Like, for every index, it is going to, for every index that I have, like this one, this and this one, I have every index, I'm just going to ask from all the neighbors that what is the minimum distance that they have, and after that I'm simply going to like minimize my distance as this. And after that, when okay, so for this purpose I will have a different array, which is, let's say, dp array. So this dp array is at last going to store all the distances, minimum distances, and then I will simply traverse this matrix and I will say, hey, whenever I have y, then I will have the minimum distance of x from y, so I'm going to minimize that distance. Okay, now from this you can observe one thing, that we have overlapping subproblems. Okay, I mean, from this you can see that we have optimal substructure. Why I am saying that, and what exactly is optimal substructure? Optimal substructure. Optimal substructure says that your solution to a problem depends on the solution to sub-problems. Like, if I have this problem, like I have to find the minimum distance of this from x, so it is depending on these problems, these sub-problems. So that's why I am saying that the solution to a problem depending on the solution to sub-problems. Okay, fine. Now let me write this. I'm going to write this. I'm just going to draw the recursive diagram that I have. What is the index of this y? It is going to be 1 comma 1, and from 1 comma 1 I'm going to make 4 calls to all the neighbors. Okay, so the call I will make is like 0 1 that I have. After that I will make, okay, 1 comma 2. After that I will make like 1 comma 0, and I will make 2 comma 1. So when I make 0 comma 1, so I'm actually moving at up direction, and when I make 1 comma 2, so it is like moving to right direction. Okay, after that if I make 1 comma 0, so it is like, okay, it is 1 comma 0, so I'm actually moving to left direction, and for this I'm actually moving to down direction. Okay, fine. Now if I call for these as well, so I will get for 0 1 I will get 0 and 0 1 call, and the another call is like 0 comma 2. Like for this 0 comma 1 I have 0 comma 1, so I can either go there, either go there. There is no more possibility. Okay, for this 1 comma 2 I will have 4 calls. I'm not going to write them. For this 1 comma 0, like this is 1 comma 0, okay, I will have 2 calls, up and down, so it will be 0 comma 0, and it will be like 2 comma 0. Fine. After that, for this I will have 4 calls as well. Now you can see one thing, here I have overlapping subproblems here. So till now we have seen optimal substructure and overlapping subproblems. Okay, so these two are the condition for dynamic programming. So you can see that we can apply dynamic programming here. And now what I'm going to do is, okay, I have explained approach here, what we are going to do. Now just let me okay, what I can do here, now I'm going to show you the approach in detail. So let me remove this as well. Okay, so I have removed all the like stuff from the page, and now I'm going to write the same example again. Okay, so I have this example, and now my approach will be, I will start a loop from this, and after that I will traverse the whole matrix. So for like row in grid, and for every column, for every row I will check every column, for column in grid. Okay, so I will do something like ask from every neighbor, ask from every neighbor. Now what it is going to ask, that minimum distance from x. Okay, and after that distance of current, like distance of row and column, like current cell is going to be min plus 1, minimum of all these values which are written by the these neighbors. Fine. Now one thing that I want to tell you is, let's see let's see this value. For this value, if I'm starting traversal from this start, like I'm starting from this point, and after that I'm moving here, here and here, here, here and here, after that I'm moving here and here, so you can see that it can give me the minimum distance, it can give me, but can it give me the minimum distance? Because I'm not done with this yet. even I have not reached this point and this point as well. So when I am starting traversal from I equals to like row equals to 0, like row equals to 0 and col equals to 0, column equals to 0, so I can only check for the up and left direction. So I can only check for up and left direction. Okay, and in order to check for right and bottom direction, I have to start traversal from this point. So this means that I will do two traversal, first from row equals to 0 and column equals to 0, and second from row equals to last and column equals to last. I hope you guys are clear what I am trying to say. So I will have two traversal, first from starting and second from ending, so that I can like check for each of the neighbor. Okay, now I am going to show you the code. You can see the code here. Okay, so on the right I have C++ code and on the left I have Java code. Fine. Now I have answer as my minimum value in order to keep track of the minimum distance. After that I have a DP which is going to store the minimum values. Fine. Here you can see that I am doing one thing, that if my current value is X in grid, then I will make my DP of ij as X, because X is at 0 distance from X, no doubt, and else it is going to have maximum value. I am storing maximum value in a cell because I want to minimize that value. Fine. Now I will do two traversal as I said. You can see that two traversal are here. First is this one and the second is this one. So here I want to tell you one thing, that here you can see that I am doing 4 calls, but I need only 2. For this I need only up call and the left call. So what is the up call? Up call is I minus 1, so I don't need this. Okay, I don't need this thing. And what is the left call? Left call is like j minus 1. Okay, I think the left call, okay, so left call is going to be j minus 1, and I don't even need this. Okay, fine. So I'm just going to have minimum as minimum distance contributed by my up cell and the left cell. Fine. Now similarly I have to do this for this as well. I have to consider only the bottom cell and only the right cell. Okay, bottom cell is going to be like I plus 1 and the right cell is going to be j plus 1. Fine. So this is what I have to do. You can do the same thing in the C++ code as well. So this is the approach that we are going to use. The approach looks very similar to what I have explained you in the board. Okay, so this is all about this problem. I hope you guys are clear with the approach. At last we are just finding, okay, let me explain you this traversal. In this traversal, what I am doing is I am checking if my grid of ij equals to y, then the value grid of ij this dp is storing is the minimum distance between x and y. Okay, so that's why I am doing this. I am traversing the whole dp array, and in this I am minimizing the distance that I have. Okay, so this is all about this approach. I hope you guys like the solution. If you like the solution, then hit the like button. Till then, bye bye.